everybody to this tutorial that is titled Visualizing a Collection of Images. Before starting,
maybe it's this. Yeah.
Right.
Did you say the first one?
Okay, thank you. Okay, first of all, thanks for being here, and I hope you will enjoy the next hour and a half we'll be spending together talking about images. Before starting, some time for the introduction. My name is Elena Aversa. I come from Italy. I am a design researcher at density design in Politecnico di Milano. And last November, I started my PhD, and my research focuses on understanding how design methods can support disclosure and critical and ethical approaches when we use data visualization. Here with me, there's Mattia.
Hello, everybody. I'm Mattia, also Italian, and coming from Politecnico, where I'm completing my master's degree of science in the final year, finally. And after spending like 5 years in Politecnico, I developed a profound passion towards web development, and I will be here today to help Elena with some useful links and so on, but also tomorrow, because we are holding another tutorial about row graphs. And additionally, I'm quite excited to be here in Lisbon, because it's going to be my city where I'm going to live for the next 5 months, because I'm going to do an Erasmus experience right here, so it's going to be exciting.
And just to add another information, we have a Slack channel that is called Density Design Desk. So if you need anything during the week, we are always there to help you. Okay, I guess we can start. Here you can find the link to the slides. I suggest you to go and add the slides on your computer, because while we are going to do the hands-on activities, you will be asked to download things or to go to specific links and etc. So as long as you copy, I will go to the next one. Where can we do that? Okay, perfect. You have it in the chat too. Okay, in the next hour and a half, we will be talking about images, and we will be trying to understand and to discover how different techniques for the observation of a collection of images. In particular, we are going to do some hands-on activities, so we will be introducing 4 different tools that are the one you can see on the screen, which are ImageJ, Imagesorter, picArrange, and picArrange. These tools are very useful when performing analysis with digital images. We are going to see in the next slide how and why. This tutorial will have a first theoretical part, where we are going to talk about doing research with images, and then some hands-on activities. This second part with the hands-on activities is going to be a little bit dense, because as you can see, we are going to go through 4 different softwares. So if you have any questions, please interrupt me, feel free to interrupt me, or write in the chat. We are going to stop and help you. No problem, feel free to interrupt. This tutorial is based on the recipes for working with images collection. That is part of a website called Recipe that was developed by Gabriele Colombo and the Public Data Lab. Here on the screen you can see the website. It is indeed a collection of digital method recipes and how-tos for doing research and for teaching. I found it very interesting because you have different sections. In each section you have different recipes that tell you how to perform specific analysis. And each section has a different, let's say, topic. So as you can see from the screen, the first section is about working with images. That is what this tutorial is based on. How does it work? This website, I mean, you find a recipe you are interested in, like for example in this case, say we want to build a grid of images. You just need to click on the recipe you're interested in, and you will be redirected to a page that explains in detail what is the recipe about, and also you have the different steps to reach the expected output. And the other interesting thing is that you have examples to understand what is the real output at the end. In this case, this is the output. The research was about images collected after a query on climate change on Google. And here you have the different steps to reach the specific output. Okay, so let's try now to understand why it's important and useful to do image analysis. Here I want you to interact a bit. So what I want to know, in your opinion, what do you see in this picture? Great, there are no wrong answers, so just what you see.
Oh. I don't know. There's like maybe one day in Instagram or something.
Was it Flickr? I think I remember this project. Wasn't it one day of pictures taken from some platform that they printed?
Yeah, so it was an exhibition that was held in the Tom Gallery at Amsterdam. The exhibition was 24 hours in photos by Eric Castle, and the Tom Gallery in that day was like full of two of these pictures. The number was something like 350,000 pictures printed. So you could see these big like mountains of pictures, and you could go through them and see how the gallery was like full of these pictures. But what I was asking was more what is happening in these pictures. I mean, you have a little kid that is watching a picture, and it's laying on tons of other pictures, and he also has some picture on his body. I think this is very powerful as a metaphor, because let's try to pretend we are these kids. We are visiting this exhibition, and we see all of these pictures. And maybe we get curious. We want to see all the pictures to understand what's inside this picture. For example, if there are pictures with people inside, or if there are pictures about, I don't know, landscapes. If we're doing that, to succeed in this goal of understanding what's inside of this picture, we need to go there, take one picture, one after the other, and watch one, then the second, then the third. This is going to be, as you can imagine, a very time-consuming process. It's going to take ages. This is why image analysis is so powerful, because image analysis gives you the tools to analyze big collections of images without having a huge effort in terms of time, in terms of analysis. So, why image analysis? Image analysis is useful to perform readings or corpora of images according to their content and their recurrent patterns, in order to take knowledge and to get insight from a collection of images, whatever it is. So we can say that it is a sort of data visualization tool. So because we start from a collection of images, and then somehow we have a visualization that gives us an insight, that gives us some knowledge. The difference, let's say, with existing database tools are mainly the inputs and the outputs. If with existing database tools, we feed them with data that can be numbers, can be dates, can be strings, and the outputs are always points, lines, bars, and so on. With image analysis tools, what we use is not data, not strings or numbers, but images. And the output we are going to get are images, both as they are, and as a summarization of their formal features. In the years, we experienced different techniques in reaching such goals. This, for example, is a grid of images, which is very useful when you have a big collection of images and you want to try to understand what's inside. Grids are based on the color components of each image. So as you can see, we have like in the middle of the visualization all the pictures with the white color inside, while in the borders we have, for example, the blue, green, and so on. This technique is very useful at the starting point of your analysis if you want to analyze your collection, because it doesn't give you like a detailed picture of what you got, but it gives you a broader picture, so you can maybe try, then you understand that maybe you want to focus on a specific part of these pictures, and then you can focus on it. Specifically, this project was about pictures about houses from Airbnb, and the focus of the researchers, let's say they wanted to understand if users also were using similar pictures to advertise their houses. This is another example of ImageJ. This project, I found it very interesting. What you can see here is images ordered not by color but by depending on the time. These were covers from the Time magazine, organized from 1923, I think, till 2009, and it lets you understand how the different covers changed along time. They started like with covers of the black and white of portraits of people, and then you can see how it changed till like more complex covers and colors. This is another, let's say, visual output of image analysis. It is a network. Networks are really useful when you want to understand the relationship between images in your collection. In this case, the relationship means the content of the image. There are some algorithms that can assign a tag depending on the content of each image, and then specialize the different images depending on their content. This project was about Paris and urban nature, and let the researcher understand what was the relationship between citizen and the city of Paris. Another interesting visual models when doing image analysis are collage. Collage are helpful when you have like small collection of images. Let's say that you have 10 images for each, I don't know, maybe social network that lets you understand how a specific topic is portrayed in different social networks. This project was about smart cities and how different cities could picture how different cities, what was the perception on Google of the different smart cities. Something similar to collage are stacks. Stacks are namely, let's say, overlapping pictures put together one on top of the other. And they are useful because lets you understand and depict common patterns inside a collection of images. As we already said, for collage stacks, you perform a stack, you decide to design a stack when your collection is limited. So when you just have a collection of 30 pictures, maybe less. Otherwise, it's going to be difficult to read all the elements. So, to recap a bit what we said so far, the visual models used to perform image analysis are mainly these four. which are grids, networks, clusters, and stacks. As you can see from the screen, networks and clusters can seem very similar. It's important indeed to understand the difference between networks and clusters because they can seem similar, but effectively they are telling two different information. Clusters are, okay, both networks and clusters are spatial disposition. This means that the images are located into a space depending on different factors. For clusters, the spatial disposition is based on the absolute position of each different image. Usually this is achieved with multidimensional reduction. What does it mean? It means that we have an algorithm that assigns a vector to each image. So all the images that have similar vectors are close together. Then there is another, okay, it's a little bit like tricky process, but the first step converts the images into a multidimensional space, so 3 or more dimensions. To have the possibility to see the results on screens or on papers, you need another algorithm that transforms the space into bidimensional. In any case, the results into a cluster, you can see that similar points are always closer to each other. With networks, instead, the spatial disposition is based on the relationship between the images. This means that each image has a tag assigned that can be assigned either manually or by a computer vision algorithm. And these tags are a description of the content of the different images. So the images are closer together when they have similar content in this case. Even if the result is quite similar, the readings on the two visual models change. On one hand, with clusters, images are clustered according to their, let's say, visual and formal features. On the other hand, with networks, they are clusters grouped together depending on their thematic relationship. So it's always important to understand what is your aim in your research and what are your research questions, and then decide for one model or the other. For this tutorial, we are going to focus on 3 different visual models. We are not focusing on networks, but we are going to see some examples of grid, cluster, and stack using the tools I mentioned at the beginning. If I'm going to pass, please tell me. Okay, the starting point of image analysis is, of course, a corpus of images. What is a corpus of images? Basically, it's a folder of images on our computer. To perform, to play with the tools and to do the different and fun activities of this part of the tutorial, you should download this folder, which is a folder that contains something like 2,000, a bit more, images about the fires in Australia. It's important that you download this folder so that you can follow along with what I will be doing on the screen. So as soon as you have downloaded it, you can maybe just tell me and I can go on. Or will you be like 1 minute? No, less than. I think of the maximum emergency.
Yeah, we are all a safe distance.
Okay. As I already said before, this part is going to be a bit dense since we have 4 tools to play with. So please interrupt me or tell me go lower or I missed a step, we will see it together, so no problem. Okay, time to play. So the first tool we are going to use is Imagesorter. If you didn't already download it, you can follow the link in the slide or the link Mattia just copy-pasted in the chat to download this software. Imagesorter is used in image analysis to build grids. So the first visual model we saw before. It is a very, let's say, useful tool to order your collection of images into a grid and clustering images by color and similarity. This is the output we are going to reach with our Imagesorter. These are the pictures in the folders about fires in Australia. And as you can see, this grid is organized depending on the prevalence of the color in each picture. We can see that we have a lot of white pictures that maybe are screens, a lot of red pictures that are linked to the theme, of course, of the fires, and then something more like heterogeneous in the borders. So first thing to do, we need to open the software. I will go to applications in my. Did you manage to download it?
Mm-hmm.
Okay. So first thing to do is to open that. Okay. This is the interface of the tool. You have a part on the left that lists all the folder in your computer, so you can see the different parts. Then you have this black, let's call it blackboard on the right, where you're gonna have the preview of your output. What we need to do is very easy to use this tool is to tell Imagesorter where is the image, the folder of images we want to visualize. So in my case, yeah, I have it in documents, I think you're gonna have it in the files. So file. As soon as we click on the folder, we have this message here telling us that the selected folder contains 2,000 and something images. To start visualizing these images, we just need to click on this button. And we have, what was I saying?
Sorry, this was a hashtag using the collection.
The hashtag, no, these were images collecting on Twitter about the fire.
How did you manage to collect it?
I think it was not hashtags. Maybe it was the whole content of the of the post.
Okay, can I ask you a simple question? What happens? My app is not showing the folder sidebar. It's only showing the little options.
Maybe you have to close
The little option you have this small thing.
Probably these two arrows there.
You have to click on that
Click
first.
that, and then the sidebar will appear.
Wait. I'll go there because I'm seeing
You don't have to type at all.
There is this sidebar here. These two arrows. This is yeah, okay, great.
So the thing you can do now is like explore your collection. You can zoom in and zoom out to see the different pictures. The only problem with the image sorter is that you cannot download this visualization. So the only thing you can do is take a screenshot of it and then reuse for your analysis. As I said before, this tool is very powerful to have a broader view of what's in your collection. So to start your analysis. So for the first one, we are done. We're done. If you have any questions, it's not the right time.
Yeah, and the level. I think one thing interesting to add is that it's kind of spherical, so it's not like it never ends because you're going scrolling and scrolling, and then you see, oh, it's repeating, yeah, because it's supposed to be,
Yeah, like a globe.
exactly like an open globe, right?
Okay. So you have the link to the slide. So in case you're going to use, you need to use some of these tools in the next days. You have all the different steps I just did with on my computer, so you can like redo them all along. So okay. The second tool we are going to use and to play with is ImageJ. Here you have the link, as we also pasted in the chat, to download ImageJ. There is also a browser version of ImageJ. There is the link you can see on top left, on top right. I won't be using the browser version for this tutorial because some features in the browser version are still not so important. ImageJ can be used to build grids and to build stacks. In the next minutes, we will be seeing how to build stacks and not grids, since we already used Imagesorter for the grids. But if in the future you need any help, we're always here to help you to get grids. So ImageJ was a tool that at first started as it was used to visualize images from a microscope. Then it was repurposed as a tool for data visualization.
Sorry to interrupt. We have a question here from Eduardo.
Yes.
I think, Eduardo, I don't know if you can hear us, but you can open your mic and ask a question.
Yeah. Hi. I just have a question about the previous software, the Imagesorter. So the pattern of organizing visuals is basically analyzing colors by pixels. So I guess it would compare pixels, density of pixels, and then arrange images accordingly.
Yes, it works on the color components inside each picture. So it analyzes the different pixels, as you said, the different colors, and if you have like a more prominent color, all the pictures would be like grouped together, clustered together. As you can see from the videos. I don't know if I answered.
Yeah. Thanks.
Okay, sorry, go on.
Thank you. So this is the output we are going to reach with this small hands-on activity. This is a stack of something like 42 images taken from the folder you just downloaded. What is important when you build stacks is that each image has to have the same size of the other one. So you cannot have squares and then rectangles, or not circles, but I don't think so. Because everything has to be comparable, since each picture, each image is stacked up on top of the other. It's important that they have the same size. I know that if you have like a big collection of images, or maybe you have not the skills to use Photoshop or any other, I don't know, graphic tool, it's gonna be a little difficult to size the images. So there are some like web-based application that helps you in doing that. One of these is bulk resize photos. You have the link in the slide also in the chat. What does it? What does this website? It lets you upload a whole, let's say, folder of images, and then you can decide how to size them. Like you decide the pixels, for example, where you want 600 by 600 for each picture, and then you can also understand decide the let's say the quality of the pictures. If it's okay and it works for you. I have already done this for you, so we don't have to waste time. At this link, you can download the folder with segmented images and also resized images. Because I forgot to say, it's also very important when you do stacks or when you do collage to focus on very small, on a very small amount of images. This means that you have to segment your collection if you have a big collection. Why segmenting? Maybe you can, let's say, you want to focus on a specific topic inside the picture. So you take the first 30 pictures with, I don't know, portraits inside. This means that you are segmenting your collection depending on a topic. Okay, so as soon as you downloaded the folder, I think you managed to do it. Yes?
Yeah.
You also have the software. I downloaded it.
The online version.
Well, I don't think Stacks works on the
Oh, no?
version. This is
Okay.
why I think that's it. Meanwhile, I think it.
No, I don't know
Okay,
the software version.
so everyone is on the same page, right? Okay, perfect. So what we need to do now is, of course, open ImageJ. I have it here. Okay. Perfect. As you can see, the interface of ImageJ is very minimal. It's just this tab. To build our stack, the first thing we need to do is to tell ImageJ what we want to visualize. So our folder of images. To do that, we just need to go on File, Import, and Image Sequence. As soon as we click on Image Sequence, we can browse the different folders on our computer. So in my case, this is the folder, File, Revised and Segmented, where we have our 42 pictures about fires in Australia. As soon as we choose the folder, we just need to click Open. Then here we have the path. Then he asking if we want a default or 16 or 32-bit RGB, etc. We always leave it on default. Filter, we don't want any filter. Then it tells us where to start and which are the steps. We are going to start from picture number 1, and we are going to take into account each picture, so we leave one in one, and then we leave the scale 100%. We are going to leave this option as you can see it on the screen, so we just need to sort names numerically, since our collection is sorted on that characteristics. The next thing to do is to hit OK. And as you can see, ImageJ is like loading our images. Then, when it stops, when it's done doing like importing the sequence, we will have this window where we have all the different pictures that we just uploaded. To see them, we can put like the example, and you can see in sequence all the different pictures we are going to use for each one. So next thing to do now, which is the last step, let's say, is to tell ImageJ we want to stack this sequence of images. So we just need to go up here on image, stacks, and then you have different models. We are going to choose the Z project that is a mathematical model that takes into account specific projection to, let's say, put together these images into a bidimensional space. As soon as we choose that projection, ImageJ is telling us, is asking us where to start and where to end. We want to, let's say, visualize all the images we have in our folder. So we start from 1 and we end at 42. Here you have different projection types. For this time we're going to use some slices because it sums the different slices that are different pictures. But you are free to experiment with all the others. These are different ways to project the images. So feel free to experiment. For now, we're going to use some slides. We hit OK, and we have our results. This is a stack of the 42 images we have in our folder. Any questions so far? Everything was clear?
Yeah, I just think I'm not getting to the right folder because mine is still with all the images.
You didn't download the...
I tried to download the second folder, the one with GIF of the cat, but it ended up giving me the same.
I think it's the same.
You may, if you follow the link, the last link I left in the chat, it should be the right one. Actually, there are not so many images. It should be the 42 one. We're going to update in the slides. Thank you.
Okay, no problem.
No, it's just because it's the same name.
Yeah, that's the problem.
the
But
only
in
thing.
the chat you have the right one.
Okay, okay. I'll get on to the
Okay, this way.
When do I even stop?
I'm copying this right now. Super slow, I am. Okay, so I'm going to upload the... Okay, that's fine now. Yeah, that should be the right one. If you go to the slide, you have the right.
Okay.
The depth.
Now, updated. Can you see it?
Now I think it works.
You want me to go through the steps again?
Yes, work like this.
Okay, let's open ImageJ. So first thing to do, file import, and then image sequence. Then we hit browse, and we choose the folder, which is fire result implemented, and we hit open. Okay. Okay, we leave the option as the are on default. And we click OK. Now ImageJ is uploading the signature images, and you should get to this. Perfect. Next thing to do is to go here on images, image, go, start, and then the project. You choose the projection type. I will use some slide.
Sorry, what project?
Z.
Okay, Z project, okay. Okay.
We have a result.
It's average intensity. Is it there? The projection type?
You can work, you can like play on them. I'd love to.
Yeah.
You can explore them.
No, I tried the. Oh, cool. It's all a cool presentation. Oh, look at it perfect.
Any question we can go on?
Yeah.
Okay, the first tool we are going to use is pixplot. Pixplot is an open source web-based software that helps you create maps of similarities. It uses Google's TensorFlow to indeed calculate the similarity between images. Pixplot is used to build grids and clusters. And this is the output that you can reach using this tool. It both shows on one side the map of similarity, so you have all the pictures mapped depending on the similarity of the content. And on the left, you have the different clusters in which these images are divided. Pixplot is a very powerful tool when you have to work with large collection of images. So if you have a folder with 3,000 images or even more, this is the right tool to use if you want to explore the content. It is also an easy way to access machine learning algorithm, and it's useful because it automatically identifies the clusters of similar images. Of course, there are some cons when using pixplot because it's a bit difficult to use it if you're not familiar with Python or if you never use the terminal on your computer, but not so tricky. We will go through it together and see that it's going to be manageable. Yes, we have a question, I think.
Yeah, it's basically also to ask how does it cluster similar images? How does it does the content comparison?
Yeah, it uses Google's flow to find a cluster of similar images. You put the Google TensorFlow algorithm.
Sorry, could you repeat that? There was some echo or something I couldn't hear.
It's to understand not because of why I'm working. It uses the Google's TensorFlow to calculate what's inside each picture. So and then it clusters depending on the similarity. We are going to see it together, so maybe you can understand better what I'm saying. But it uses Google's TensorFlow. So the other con when using pixplots is that you cannot export your visualization, but you can take screenshots as we saw with the Imagesorter. What you can download is also the list of the different clusters that the pixplot recognize. So useful. Okay, this is the folder you should use that we are going to use with pixplot. I think it was using. It's always the folder with the fires. I think that this is we have a less number of images. I think it's 1,000. Let's see.
It's fires on the right 1,000, the name of
Okay, perfect. So
it's probably, yeah, it's a hint.
Perfect. I like reduce the size of the number of the images because the more images you have, the longer it's going to take to reach the results. Okay, a small disclaimer, this part of the story is going to be on the Mac, but I see everyone here as a Mac, so I'm not.
There's two.
But I think it's two, we have also. Okay, but it's quite similar also on Windows. Maybe the only difference is that on Mac we are going to use the terminal, there you are going to use the control prompt. Okay. Okay, first thing to do is to open, or not to download and install Anaconda. I put the link in the description of the lab, the tutorial, but if you didn't already download it, you can follow the link on the slides or the link at the end and copy paste in there. Thank you. As soon as you're done, it's like not 5 minutes.
The graphical installer almost.
No, download the graphical, the first one.
This is me not reading the terms and conditions. Yeah. That's it,
As we
every
all
day.
do.
As we all do.
Daniel? Yeah, it's gonna be a bit tricky, so we are on the same page. Okay. After downloading and installing Anaconda, what we need to do is to create a new environment using Anaconda that uses a specific version of Python, which is the 3.7. To do that, what we need to do is open the terminal, in the case of the Mac. Instead for Windows is the command prompt, right?
I think that if you install the Anaconda, I think the toolbar with the visual UI, you can open the Anaconda prompt.
On Windows?
Yeah.
Okay. Okay, so they just said, what?
It works.
It worked. So if you have Windows, you just need to open what you just downloaded and run it. So to do that, so to create this environment using Anaconda Python 3.7, what we need to do is to copy this command, these two lines of command inside our terminal. Okay. In the chat, we put the lines of command. Please copy without the $sign. That's the thing we have in the chat. So we paste it, and we hit enter. At this point, Anaconda asked us if we want to remove the existing environment, since I already had installed it in the previous days. Let's say that we want to start from scratch, so we say yes, we write like Y and hit enter. And it starts working. Then it is everything okay?
No, I mean, it's not the same as something we want. Which sign shouldn't copy?
The first, the sign, the dollars, we have to delete the dollars. In the chart.
I don't know, because I'm copying from the
this is okay.
presentation.
From the
Yeah,
presentation,
gotta leave it like
okay.
that.
You leave it like that.
Or search file or directory, I know it's to. Go on. I'll catch up that.
So, Anaconda is asking us if you want to follow in the installation of this environment. Of course, we say yes. Hit enter, and our environment is going to be created inside Anaconda. As soon as we have as soon as we can see the 3.7 label on our terminal, it means that the process is done. So we succeeded with the terminal, our computer succeeded in creating this environment. Okay, after running these two lines of command, the next thing we have to do is to install pixplot. So the second two lines of command we have on the slide are used to, on one hand, uninstall previous version of pixplot you may have on your computer. I think this is not a very good. And then install the version we need. So we copy these two lines and we paste them inside our terminal and we hit enter. This is gonna take a bit, but we know that the process will be done as soon as we saw again the 3.7 label.
Now it works because the first time I pasted there, it was with a space in the end, so it was not working. Then I deleted the space in the end, and then it worked.
Ah, okay.
Yeah, it was just
It's always like this.
I assume it was something stupid like this.
Okay, now it's telling me 47 hours.
Well, you know, the sprint's until Friday, so you have time for it. Yeah, I mean.
You have time.
14 minutes.
Okay. If you're
It was
done,
going like this before, and then it's going like this.
Let's wait. Okay, so pixplot is installing. The next thing to do is to start using pixplot. So we have to tell pixplot, please, pixplot, take this folder of images and start analyzing them. To do that, we move to the next slide. To do that, we need to, let's say, locate the folder of images we are going to analyze and tell pixplot to go to this specific path. We have to copy this command you can see here, but we have, instead of this path to image that is in blue, we have to copy inside the actual path of our folder. How to do this? I will be doing this into a text editor, so it's going to be easier to modify it. So if you open a text editor, well, you can also do it inside the slide, okay? You copy paste this line of command. What we need to change is this path to images to understand, to get this specific path on Mac is a little bit tricky than Windows. On Windows you have already in your folder. For Mac we just need to go to our folder, and in my case it is in the documents, and it's the Fire 1000. Right click, hold Option, and you can see that here we have copy the folder as a path. We copied it. We go back to our text editor, we delete path to images, and we paste our actual path. Then we copy everything. Is it working? Yeah.
Yeah, I couldn't find the option part, clicking on the right side.
You first, okay.
I click here and then.
You right click on the folder. Why do you are right clicking?
Now, this one here.
Ah.
You see copy, like about share.
Copy
Okay,
as
that-
a pattern? No.
the one
Oh,
about,
here.
yeah. Okay, now you have copied the relative
Now I
path
can
of
paste
the
it
folder.
there.
Yeah, exactly.
Thank you.
Okay. So we go back to our terminal. We paste this comment and we hit OK, enter. So now pixplot is analyzing what's inside our folder. This may take some minutes. It depends, of course, on the, let's say, amount of picture you want pixplot to analyze. So it will be, if you have any questions, by the way. It is important that when you copy your path, you do not delete the last part, the JPEG part, since it tells your terminal that it has to look for the JPEG in your folder. The other important thing is that your folder has to contain JPEGs. So in case you have PNGs or other formats, you can use the website we saw before, the bulk resize, and transform your images into the JPEGs. Okay, you can see that we have these bars logging. This means that the pixplot is analyzing the content of our images using Google TensorFlow. My computer is like lying. We are done. I mean, my pixplot finished. What about yours? You're running.
Mine is not even
Start.
installed, I guess. I had a very weird error.
Let's say.
It started by saying, in the middle of the installing building dependencies L, and then a bunch of error lines in red,
But this,
a lot, and then it started installing software outside of
which step are you in? Are you talking about the first one?
the first one, where
The
the
creation
installing.
of the environment.
No, after creating the
The
environment,
pixplot.
the installing the pixplot failed, I assume.
Let's see. Usually when it doesn't work, what I do is close everything and restart.
Yeah, it started like this, it was going okay, all the things, and then it gave me this error. The first one, the one with this one, with the graphical modification. Yeah, but because then it started installing something, which doesn't let me talk.
So that's the problem, I guess.
Yeah.
Maybe you should close.
I think it's solved, but now when I paste this comment, it says like a little hotline section. It's this code part of some, or it's not. Well, with a password here, yes, and then, but, maybe we can try another photo. Yeah, I mean, yes, I think that we can try, it doesn't have to be the same size, right?
No,
Okay, I can try a different one.
maybe not so big.
Yeah, I have one small, because
I know the problem is that you downloaded that folder from the internet, so
I
the
have,
iOS is always like,
I have one like done the mall that I needed recently, and this one, yeah, it's like this from lots of text on Instagram. Yeah,
you can try.
I think it works as well.
But because the first time I used it, I had a window like asking me, do you want to go to permission to the terminal to do this thing? Did you?
No, it didn't appear in like,
Maybe it depends on the, we can check better if it doesn't work with it.
okay.
Folder. Okay.
Doesn't execute the comments.
So pixplot analyzed our images. The next thing to do is to actually open pixplot and see the result. To open pixplot, what we need to do is to let's say create a fake website local on our computers to see the output. To create our, let's call it fake website, we need to copy either the first or the second command you can see on the slide. Why? Because here you are telling the terminal to build a fake server using a specific port. I copy pasted the two options because with my in my computer this port is already like blocked on something else. So it would work with the 8000 port. So in my case, I would be using this. But this depends on your computer, so you can also write another number of another port. So we go back to our terminal. We paste this command and we hit enter. So now the terminal is creating our local server and our local website. To access the output, what we need to do is to copy paste this address inside our browser. Of course, now here you have 5000, but if you use the 8000 port, here you have to write 8000. Okay, so we open a new tab. Okay, this is pixplot, the interface of our fake website. Did you manage to read it?
Mine is still analyzing.
Okay, still analyzing. Okay. So this is what we see when we first open our fake website. We have a description on what we're going to see. And we have here we have 100%. This is the progress of our analysis. This means that your visualization is ready to be explored and that everything went well. So we just need to hit enter. And here we have our visualization. Yeah. So these are our clusters that we can zoom in and browse and like start our analysis. On the left, we have the different clusters. As you can see, while I hover each cluster, we can see inside visualization the affected cluster I am following. What you can do is download this list, as I said before, but you cannot download this visualization. Of course, you can take screenshots. Maybe you want a cluster and you want to take screenshots. If the features are overlapping and you want to have like a better view of each single feature, you can tell pixplots to avoid overlapping between images. To do that, you just need to go here on settings and check this box. You can see now that all the images are not overlapping anymore.
Almost that.
Yeah. Then you have an option on the borders or on the side of the images. Like this. Another interesting thing you can do with pixplot is not only visualizing these clusters, but also organizing them into grids. Take into account that the grid is not, let's say, precise in this case of a cluster, since pixplot is forcing the images to be on a grid and also considering the different clusters. But to see the results, we just need to click here on the icon, and we have a collection ordered into a grid. So far we are done. We are done with pixplot. If you have any question or any doubt, please ask it. Okay.
I can't access the virtual server on the port.
Because the port is blocked.
I don't know.
Change the number.
I'm trying to terminate the process and reopen a new.
Start again. To start again.
Yeah, to start again, not the old process, but only the part of the virtual server.
Okay. I think the only problem is that you have that port already blocked, maybe. Which one you use? What happened?
8,000.
Maybe on Windows is better to use you have Windows.
Yeah.
Try to change the port, and I think it's gonna work. The first time I tried with the 5,000 and it was blocking me, telling me that I couldn't access the port. This means that something else is already running on the port. Anyway, we can look at it together later, maybe. Okay, we have like 10 minutes left. In the slides, we have a last tool that I think we can skip, but you have the slide, so you can check it. Since this is a tool only available for Macs. But it is very useful because it allows you to browse a folder of images on your computer as if you were using your Finder, and you are able with this tool to navigate the folder of images on your computer based on color similarity, and also on different other format features. What you can do that I found very like helpful is to search for similar images. For instance, you have one picture and you want to search all the similar pictures to that one. You can do it with the application. And it's also easier when you want to segment your cluster of images, as we did before to build the stacks. Maybe you want to segment your folder of images depending, I don't know, you want just the right pictures, you can use picArrange to do that. So you can go through the slide and see everything detailed, if you have a Mac, otherwise I'm sorry. And that's it. I think if you have questions, we have 10 minutes. So yeah, so we reached the end of this practical lab. I hope you enjoyed it and you found it useful. And many thanks for being here, and bye bye everyone.